Quick revision video on hydrated salts. So essentials first. When some salts form, there are sometimes water molecules loosely attached to the ions in the crystal. So a hydrated salt is a salt which contains these water molecules. The number of water molecules involved is shown in a dot formula. So the formula for hydrated copper 2 sulfate is CuSO4.5H2O. When hydrated salts are heated, the water is driven off and the compound left over is what we call the anhydrous salt. So the equation for hydrated copper sulfate would look like that. So CuSO4.5H2O, if you heat that, it becomes CuSO4 and 5 H2Os. And finally, the water molecules in a hydrated salt are what we call water of crystallization. So we'll just quickly look at the typical experimental setup to determine the formula of a hydrated salt. So typically you'd use apparatus like that, where you'd have your hydrated salt in a crucible and you'd heat it with a Bunsen and obviously drive the water molecules out. So the data you'd need to collect would be the mass of the empty crucible. You'd need to know the mass of the crucible with the hydrated salt in. You'd heat that up till constant mass, so obviously that means all the water's gone. You'd weigh the crucible again, but this time it's got the anhydrous salt in. And you'd use those mass results to determine the mass of the hydrated salt. So that would be this value here minus the empty crucible. The anhydrous salt will be this value here minus the empty crucible. And the water would be the mass of the hydrated salt minus the anhydrous salt. It's also worth saying at this point that you can also determine the MR of a hydrated salt and therefore the number of waters of crystallization by titration. So the questions are coming next. I've chosen two questions that involve this method here, and the final question is a titration example. So here they are. So if you want to pause the video, have a go at those questions and then play on when you're ready for the answers. So the first type of calculation is a bit like an empirical formula calculation. So we've got the mass of the hydrated copper 2 sulfate crystals, heated at a constant mass, and we're told that we've got 4.35 grams of anhydrous salt left. So the mass of water is obviously the difference between the two masses, 2.45. We divide by the MR of those two substances, so 159.6 and 18. That's going to give us the moles of each substance, and then we just divide by the smallest to get the ratio, coming out at 1 to 4.99, so in other words 1 to 5. So the formula, the dot formula for this will be CuSO4.5H2O. So fairly straightforward, hopefully, that one. So type 2 is a little bit different. So the first thing I'm doing is working out the mass of the hydrated salt, anhydrous salt and water. So the hydrated salt is obviously the crucible anhydrated minus the empty crucible. So that comes out at 6.57. Anhydrous is the crucible with the anhydrous in minus the empty crucible, 3.27. And the water is the difference between those two answers, 3.30 grams. So they've heated up this hydrated salt, XCl2.6H2O, to constant mass. And so the equation to represent that process would look like that. So the first thing we can do is calculate the moles of water that's come off, because we know the mass of water, 3.30 grams. So that comes out at 0.183 moles. So mass over MR to get those moles. We're now going to use the mole ratio in this equation to work out the moles of this we must have had. So that's going to be a sixth of 0.183. So that comes out at 0.0305. Now we know the moles of that, we can work out the MR of the XCl2 6H2O, mass over MR, so 6.57 over the moles, so we get an MR for the hydrated salt at 215.4 grams per mole. So that's the first part of the question answered. To work out what the metal X is, we subtract from that MR the mass of 2 chlorines and 6 waters, so that comes out at 36.4. And finally X, well, it's got to be in group 2 because it's XCl2. Remember, each chloride ion has a 1- charge, so X has got to be 2+. and so therefore its calcium would be the closest match. So finally there's the titration example. So they've taken 27.93 grams of hydrated sodium carbonate and dissolved it in water and made it up to 1000 cm cubed, and then they've taken 25 of that and done the titration on it using that volume and concentration of nitric acid. Essentially what we're going to do is calculate the MR of this and then take off what we know and work out how many waters must be making up what's left. So the first thing we can do is calculate the moles of nitric acid, concentration times volume. The moles of sodium carbonate using the ratio is going to be half of that, and remember that's the moles in 25 cm cubed of the solution. The 27.93 grams actually made up 1000 centimeters cubed, so the moles in the 1000 is going to be 40 times these moles here, so that's 0.0976. So the MR is therefore the mass 27.93 over those moles. That comes out at 286.2. So a little bit like what we did before, we subtract from that what we know about the formula. So Na2CO3 can come off. That's got a mass of 106. So the X waters come out at 180.2. And each water molecule has an MR of 18. And so therefore there must be 10 waters in this salt. And so it's Na2CO3.10H2O.